The question of where life began is a difficult one to answer. While many scientists believe that life began on Earth, others believe that life, or at least its building blocks, first formed in space. A recent study from the University of Sherbrooke in Canada has shown how complex organic molecules could form on icy comets, from nothing more than simple molecules and radiation. And it's possible that this could explain how complex molecules like amino acids, which are the building blocks of proteins, could have originally formed billions of years ago and led to the beginning of life on Earth. Michael Hughes, who led the study, told us more.
It's been known for quite a while that there are organic and in some case biological molecules that can be found in space. And what has been proposed is that some of these molecules that have been produced in space over billions of years at some point have arrived on Earth and have sort of become the seed for life on Earth. And our interest is to look in greater detail how what's called secondary electrons that are produced by the high energy ionizing radiation, which permeates space, how these secondary electrons can induce the formation of a more complex molecule in a film that contains, for example, methane and oxygen.
So what did you do in this study? How did you test this idea?
The way we go about this, we make a film of these molecules in a vacuum system, which is under very, very low pressure. So it's a very small fraction of atmospheric pressure. And we bombard the film with electrons, low energy electrons. And then we use various surface science techniques to see what new molecules have formed in the film.
And what did you find?
We see the formation of things like ethanol, for example, which contains 2 carbons, 5 hydrogens, and an OH group, which is basically an oxygen atom with a hydrogen bound to it. Right? So this is basically a much more complex molecule than the simple methane and oxygen we've deposited in the film. So the study basically shows that these electrons can induce the formation of a more complex molecule.
And you think that the building blocks of life could have formed in a similar way?
Well, the building blocks of life depends at what level what you're talking about, right? If you're talking about simple things like amino acids are like the building blocks of protein. Ethanol is great to have around, but it's not a building block of life. The question is, this is just looking at the fundamental mechanism by which these electrons can do their work. But our ongoing experiments clearly show, for example, if you're talking about amino acids like glycine, the simplest amino acid, that at least in the lab, in a condition which sort of vaguely resembles conditions that can be found for various astrophysical or planetary ices, you can imagine that you will be making a molecule such as glycine. So I think in principle, yes, you could make successively over astronomical timescales, you can make molecules which could be called the building blocks of life.
So if these complex molecules are forming in space, how would they then get onto the Earth?
These molecules, for example, if they form on the icy mantle of a comet as it goes around the sun, and it gets close to the sun, it's exposed to the solar wind, and you get massive amounts of ionizations going on. That's why you see the comet's tail, right? So people have found that you find relatively complex molecules on cometary ices. And now, even nowadays, sometimes we get meteorites that hit the Earth's atmosphere, and some of them make it down to Earth. Now, the notion is, the hypothesis is that in the early days of the Earth, when there was heavy bombardment by meteorites, that these building blocks of life, quote unquote, arrived on Earth.
If the basic building blocks of life could form in space and not just on Earth, does that mean that there could be life on other planets?
Space is immense, and the probability is there is life on other planets, whether it's similar to ours. We don't know. I think what these experiments show that this is a very fundamental process, which takes 2 things. It takes matter and it takes ionizing radiation. And we know that there is a lot of matter out there, not just our galaxy, but throughout the universe. And there's ionizing radiation whenever you have stars that undergo nuclear fusion. So since there is ionizing radiation and matter, for example, in the Andromeda galaxy, one can imagine that if the ingredients are methane and oxygen and maybe ammonia or CO2, It could possibly mean that somewhere in the Andromeda galaxy, there is some icy mantles in an interstellar cloud, and it's being irradiated by a nearby star. Then there's a good chance things like lysine or other similar biological molecules are made in those ices. Whether or not they will rain down on a planet in some faraway planetary system and create similar, or at least mediate the formation of similar life forms on Earth, we have no clue.
That was Michael Hewells, and the work was published in the Journal of Chemical Physics.